Hello, I'm Terry O'Brien from the University of Melbourne and the Royal Melbourne Hospital, and today I'm going to talk to you about the effect of anti-epileptic drug exposure in utero on the developing brain. Epilepsy is a chronic condition for which there is currently no curative treatment. Therefore, many women need to continue to take anti-epileptic drugs during and following pregnancy to reduce the occurrence of seizures, which can have serious safety, health and social consequences for them, their babies and others. It is now widely recognised that children born to women with epilepsy who are taking anti-epileptic drugs during the pregnancy have an increased risk of having a birth defect, which is overall 2 to 3 times that of the general population. While there are a number of factors that could contribute to this risk, it's generally believed that the greatest effect is from the anti-epileptic drugs, with higher dose valproate carrying a particularly strong risk. The risk of birth defects is confined to the first trimester, the primary period of organogenesis. The neural tube closes by the end of the 3rd week post-conception, often before the woman even realises she is pregnant. Therefore, it's been common clinical practice for doctors to recommend that after the first few weeks, the primary concern should be about optimising seizure control. However, the human brain development is a long and highly complex process, which extends far beyond the first trimester of pregnancy through gestation and postnatally through infancy, childhood, and even teenage years and beyond. Therefore, the time window in which there is potential for anti-epileptic drugs to induce damage to the brain structure and function is very wide indeed. However, obtaining objective clinical evidence is easiest for the early effects, as birth defects are a hard endpoint that's relatively easy to measure, while measuring effects on endpoints such as cognition, personality, behaviour and motor development is more difficult and is often confounded by other factors such as socioeconomic issues. The cellular processes of brain development are multiple, including neurogenesis, synaptogenesis, apoptosis, synaptic pruning and glial development and myelination. Anti-epileptic drugs have shown in experimental animals to have effects on all of these. The best studied experimentally is the effect of several, in particular phenobarbital, valproate and phenytoin, to induce increased apoptosis of neurons during a vulnerable time window of the rapid brain growth spurt, occurring postnatally in rats in the first 2 weeks and corresponding to, in humans, to a period from the 3rd trimester to the end of the 2nd or 3rd year postnatally. As I've previously mentioned, the question of whether these adverse cellular effects of anti-epileptic drug exposure is translated into significant harmful neurocognitive and neurobehavioural effects in humans is a difficult thing to study. One of the best and most important studies addressing this issue was published relatively recently by the NEED collaboration of US and UK researchers in the New England Journal of Medicine in 2009. This paper reported a prospective observational multi-centre study with blinded cognitive testing at 3 years of 309 children who were exposed to monotherapy with valproate, carbamazepine, lamotrigine or phenytoin during pregnancy, adjusting for many of the potential confounding factors. The results showed that children exposed to valproate in utero had a significantly lower IQ than those exposed to any of the other 3 drugs, which were all around the range of the normal population. There was no non-AED exposed control group, unfortunately. However, it is critical to look at the data when stratified by dose, with the effect of valproate only being significant in mothers who took the dose more than the median of 1,000 milligrams per day. So to conclude, the experimental and clinical evidence to date indicates that AED exposure in the developing brain can produce adverse effects that extend beyond birth defects to include neurocognitive and likely also neurobehavioural and neuromotor effects. Certain drugs and doses are associated with the greatest risk. However, these effects need to be balanced against the risk of uncontrolled seizures when deciding the optimum management strategy for women with epilepsy during pregnancy. Thank you.